Hi, everyone. Today's lesson has us comparing functions. When we are comparing functions, essentially you're taking your information that can be represented in a linear equation like your slope and your y-intercept, and you are comparing that. But it's not going to say just compare the slope or compare the y-intercept. It is going to ask questions, and you have to know what it's referring to. So when it comes to functions, we've already talked about the fact that slope is called rate of change, and y-intercept can be called initial value, which is a word I talked about when we were looking at situations with slope and y-intercept. It's the same basic thing. So this information can be represented to you in a graph, an equation, a verbal description, and a table. All right, so let's look at an equation first, and let's look at what information we can get from it, what we can do with it, and the types of questions you might be asked. Then I'm going to take you through the same type of scenario, but in a table, and talk about the questions. And then we'll actually compare them. And then I'll take you through one question, which will be like your homework questions, where you'll just be asked to compare things. So Lynn's mother gave her a plant. The equation y equals 5 plus 1.5x represents the height of the plant in centimeters after x days. So there's many different parts to this equation. There's your y value. When we solve this equation, we're solving for y, and that will give us the total height of the plant. You have an x variable. Your x variable represents the number of days since Lynn received the plant. So right here in our verbal description, it talks about after X days. That's how it's telling you that X is represented by days. Your y-intercept, which in this case is 5. And in my introduction, I talked about how it's a starting point or an initial value. Well, what would a starting point for this situation be? What could the 5 represent? Well, if we're talking about the height of a plant, it would be the height of the plant when Lynn received it, from when she took over control or physically having that plant. So how tall the plant was when Lynn received it. Your slope is always your coefficient of x, which in this situation, we call it a rate of change. It's the rate at which something is changing. Well, what's happening in our situation? The plant is growing. So it's the rate at which the plant is growing. So now you can use your equation to determine the height of your plant after a specific number of days. If you want to know how tall it will be after 2 weeks, after 3 weeks, or X certain number of days, you can do that. So let's take this same information and let's ask some questions about it. How tall was the plant when Lynn received it? Well, we kind of already went over that. When you're asked how tall the plant was when Lynn received it, you've got to look at your equation. We have y equals 5 plus 1.5x. You have two numbers there, so really two possible answers, 5 and 1.5. Well, you have to think about what each of these numbers represent. 5 is your y-intercept. It's a starting point and an initial value. And 1.5 is your slope or rate of change, the rate at which something is changing. So look at your question. Is your question trying to ask you about a starting point or the rate at which something is changing? How tall was the plant when Lynn received it? Talks nothing about a rate or something changing. It is talking about how tall was the plant when she got it. So it is 5 centimeters. Our next question, at what rate did the plant grow? Now, sometimes you will see the word rate right in the question. Sometimes it will use a different word that's indicating a rate. You have to know the difference. So at what rate did the plant grow? We know that's referring to the rate of change. We look at our equation. Our rate of change is our slope. Our slope is our coefficient of x. Our plant grew at a rate of 1.5 centimeters per day. How tall will the plant be after 20 days? If you go back into the situation, again, it says after X days. We talked about the fact that X represents the number of days since you've gotten the plant. So you will simply substitute 20 in for X in your equation and solve it. So we take our equation, y equals 5 plus 1.5x. I simply replace X with 20. That means I need to multiply first. 20 times 1.5 is 30, and 30 plus 5 is 35. So after 20 days, Lynn's plant will be 35 centimeters tall. Now let's look at a very similar situation. Sally received a plant from her father, but all your information is not in an equation this time, it's in a table. But you're going to be asked the same type of question. So the table below represents the height of the plant in centimeters daily. So let's go through the same 3 questions, but now we're looking at this table to determine our answer. How tall was the plant when Sally received it? Okay, we talked about the fact that asking how tall the plant was when she received it, that's her starting point with the plant. That would be your y-intercept. So what you have to come over to your table, and if you remember when we did slope way back, back in like January, your y-intercept, if you put it into an ordered pair, is 0, comma, a y value. So in this table, your left column is your x column, your right column is your y column. So your number of days are your x values, your height are your y values. And I can see I have an x value of 0. If you have an x value of 0 on your table, you have your y-intercept. So your height is 4. For what? If I go back up into the verbal part, it tells me it's in centimeters. So how tall was the plant when Sally received it? 4 centimeters. Next question. At what rate did the plant grow? Within the last few lessons, I've talked about finding a rate of change or a slope from a table. You could just pick your 2 ordered pairs and do y2 minus y1 over x2 minus x1, which is essentially what I'm going to do here, but this is a little bit easier of a way. We can think about slope or rate of change as rise over run. Our rise is our vertical axis, or our vertical change, which would be a change in our y values. So I'm going to see how are my y values constantly changing here. I can see that my y values are increasing. They go from 4 to 12. And if I look at them just from one row to the next, 4 to 6, 6 to 8, 8 to 10, 10 to 12, it's constantly increasing by 2. So this right side, or my rise or my y, change in my y values, is plus 2. Now we look at the left side. We have 0 to 1, 1 to 2, 2 to 3, 3 to 4. This is constantly increasing by 1. So if I put it together, my rise is 2, my run is 1. They're both positive. It is growing at a rate of 2 centimeters per day because 2 over 1 simplifies to just 2. Again, after 20 days, how tall will the plant be? This becomes a little bit trickier because we can't just substitute into an equation. But at the same time, you could easily write an equation. You have your slope and your y-intercept. You could use that. You could also just kind of extend out the table and keep going. Days, 5, 6, 7, 8, 9, 10, 11, 12, etc., all the way up to 20, and obviously keep adding 2 here. I would choose to write the equation y equals 4 plus 2x and simply replace x with 20. How did I quickly write this? Again, I'm kind of modeling it after the last equation, the last question with Lynn and her plant, but we just answered this. This was my y-intercept, a 4, so it's just a 4, and then the rate is my slope, so it's 2, so y equals 4 plus 2x. If I can get this to move away, you can see that I substituted in y equals 4 plus 2 times 20. 2 times 20 is 40. 40 plus 4 is 44. So now let's take these 2 situations and let's compare them. So 2 friends were given a plant on the same day. The equation in the table below represent the height of the plant. So here's our table from Sally's plant. Lynn's plant is represented by this equation. So even though I just took you through the 2 situations separately, this is the type of questions you're going to be receiving on your homework. You're going to be just given a table and an equation, or a graph and a table, or any 2 different versions, and you're going to be asked to compare them. So we're going to be asked whose plant was taller when they received it, whose plant grows faster, and whose plant will be tallest after 20 days. Okay, so what I just did is took that information and that we just figured out separately and just kind of put it into this table. You would not be doing this separately and then comparing them together. You're just going to be asked to compare them, but you've just got to be able to read through the questions and determine what they're asking. So in my table I created here, my left side is for Lynn, my right side is for Sally. Whose plant was taller when they received it? That would be referring to your y-intercepts. So we talked about Lynn receiving it. When Lynn received it, it was 5 centimeters tall. When Sally received it, it was 4 centimeters tall. Whose plant grew faster? Lynn's plant, we determined, grew at a rate of 1.5 centimeters per day. Sally's grew at 2 centimeters per day. So we can use that information to answer that question. And whose plant will be tallest after 20 days? We had already figured out how tall their plants would be after 20 days. We determined Lynn's would be 35 and Sally's would be 44. So when you get to the questions you have for your homework, you're going to need to determine, you're just going to receive these types of questions. And you're going to have to ask yourself, is it asking me for the slope or the y-intercept or the rate of change or the initial value? And determine that. So whose plant was taller when they received it? Okay, so that's talking about your y-intercept. And obviously we know that Lynn's was taller because hers was 5 centimeters when she received it and Sally's was only 4. Whose plant grows faster? Now, the word rate was not used there, but you should know that when a plant is growing, it's growing at a specific rate. And that's where we would look at our slopes or our rates of change. And therefore we would look at the rates of change that we determined. Lynn's was at 1.5 centimeters per day. Sally's was at 2. So I know that Sally's grows faster because it grows 0.5 centimeter more per day than Lynn's. And whose plant will be tallest after 20 days? Well, I showed you how to determine how tall each plant would be after 20 days. And we recorded it here. So Lynn's would be 35 centimeters after 20 days and Sally's would be 44. So whose plant would be taller after 20 days? It would be Sally's because hers is 44 centimeters tall. Now, here's the type of questions you're actually going to be receiving on your homework. So I'm going to go through one of these questions with you. Fred and Joe are emptying their aquariums. They both began emptying the tank at noon. Fred's fish tank is represented by the graph and Joe's by the table. So here's the questions you're going to be asked. Whose aquarium is emptying at a faster rate? Whose aquarium had less water before they started emptying their tank? And how much water will Fred's aquarium have in it at 6 p.m.? So the first thing I would do, because we want to answer the question, whose fish tank is emptying at a faster rate, you need to remember, back at this question, this verbal part is always really important. Notice that the graph nor the table really indicates which information is for who. So you always have to go back to the verbal part or the written part and use it. So the first thing I would do is label it. Fred was the graph, Joe was the table. And physically write that down so you can see it. Now, let's talk about whose fish tank is emptying at a faster rate. Well, this question actually has that key word in there, rate. So we know that therefore we're using the slope and the rate of change. I'm going to look at my graph here and I need to determine my slope or my rate of change. So I'm going to start with this point right here because it's a point at the cross of the grid marks. It's actually the point kind of 0.5. And I'm also going to use this point right here. Now, I see that it is decreasing left to right, so I know my slope will be negative. But we're going to remember, when it comes to situations like this, we are not going to use negative signs, but words to describe that negative. So it is going down to right 4. So down to right 4, which really reduces to 1/2 or 1/2. So Fred uses 1/2 or 0.5 feet per hour is how much of his aquarium is emptying. Joe, if you look at this information, it is decreasing in the top is your X values, the bottom is your Y values. So although we always look at the Y's first because that's kind of our rise, it is decreasing 1.5, 1.5, 1.5, 1.5. And then my X values are increasing by 1. So this is -1.5 over 1. So it's decreasing 1.5 feet per hour. So Fred's fish tank is losing water at a rate of 0.5 foot per hour, where Joe's is 1.5 feet per hour. So Joe's fish tank is emptying faster. Whose fish tank had less water before they started emptying their tanks? Again, making sure that we've labeled that the graph is Fred and the table is Joe, so we remember which is which. Now, when we're asked a question, whose fish tank had less water before they started emptying their tank? So how much water did they have in it before they ever started emptying it? That would be our initial value, our starting point, or our y-intercepts. Okay? So here on Fred, we can see that at noon, if you remember back from that verbal description 2 slides ago, it said they just began emptying their fish tank at noon, and his fish tank had 5 feet of water. His aquarium had 5 feet of water in it. Okay? Now, granted, Joe's is a little bit different. It just says time in hours. Well, 0 hours, which means they haven't begun emptying the aquarium yet. Now, how do we know it's about the same thing? If you remember 2 slides ago. Oh, here we go. Got to go back through all this. Sorry. It says that they both began emptying the tank at noon. So although the table or the graph on this one shows you that it began at noon, this one's written a little bit differently, time in hours. It's been 0 hours since they started emptying it, and therefore that is also noon. You have to be able to read through that information. All right, let's get this all back so I can. So Fred's graph started at 5 feet. For Joe, it tells us that at 0 hours, or before he started emptying the aquarium, there was 8 feet of water in his tank. So Fred's aquarium had less water in it before it started to be emptied. So this answer would be Fred. How much water will Fred's aquarium have in it at 6 p.m.? Generally, there's a question asking you to predict some kind of information. So to be able to determine now, if we're talking about Fred, we're looking at the graph here. Now, if I just look at this, although I know this is being covered up by this, it ends at 5 p.m. So I cannot see how much water will be in Fred's aquarium at 6 p.m. But I know that Fred's aquarium is losing water at a rate of 0.5 foot every hour. So I know I can go down 1, right 2. And if I do that, that'll be 6 p.m. because that'll be 1 hour later because this is increasing in half-hour increments. So if I go right 2, this is at 5, this is 5:30, it would be 6 p.m. And I've only gone down 1, which would show me there would be 2 feet of water. So you have to use your rate of change to help determine. If Fred's tank is losing water at a rate of 0.5 foot every hour, and at 5 p.m. there's 2.5 feet of water, the tank will lose another 0.5 foot of water over the next hour. So at 6 p.m., it will have 2 feet of water left in it. I hope this lesson and my explaining has helped you. Of course, we will have a meet at 12 or 12:30, depending on what class period you were in today. So you can bring questions if you have them. Feel free to email me if you don't make it to the meet and you still have questions. I've also attached this slideshow without me speaking through it, with just all of the information on it, so you can go back and use it as a resource as you start answering your homework questions. You have 2 questions that has you comparing functions. Good luck. Remember those keywords that represent slope and y-intercept, and think carefully.